In November 1904, Benjamin Holt stood in a muddy field near Stockton, California, watching a 40-horsepower steam tractor sink slowly into the soft delta soil. The machine, weighing thousands of pounds, was one of his company's best designs, equipped with the wheels 7.5 feet tall and 6 feet wide. Yet despite its enormous footprint, the tractor sank deeper with each revolution, its wheels spinning uselessly in the spongy peat. Farmers in California's San Joaquin Valley faced this problem constantly. The rich soil that made the region ideal for agriculture was so soft that wheeled equipment became mired after a few passes. Holt had tried everything: larger wheels, wider wheels, multiple wheels. One experimental tractor was 46 feet wide, its massive wheels making it impossible to maneuver. The solution, when it came, seemed obvious in retrospect: don't use wheels at all. On Thanksgiving Day 1904, Holt and his assistants removed the rear wheels from steam tractor number 77 and bolted wooden slats to a continuous chain, creating a moving track that distributed the tractor's weight over a much larger surface area. The machine crawled forward, its tracks laying themselves down in front and picking themselves up behind like a portable road. The tractor didn't sink. It moved steadily across ground that would have swallowed wheeled vehicles. Company photographer Charles Clements, watching the machine creep forward, reportedly said it looked like a caterpillar. The name stuck. Holt patented the track-laying design in 1907 and began manufacturing Caterpillar tractors for farmers working soft soil. It was an agricultural innovation designed to solve a local problem. 10 years later, it would reshape warfare. Benjamin Leroy Holt was born on January 1, 1849 in Concord, New Hampshire, the youngest of 8 children. His father was a teacher and timber merchant who moved the family to New York and later to California. Benjamin studied mechanical engineering but never graduated, leaving college to join his older brothers in the family's hardwood lumber business. In 1883, the Holt brothers founded the Stockton Wheel Company in California, manufacturing wheels for wagons and farm equipment. By the 1880s, California's Central Valley was becoming a major wheat-growing region, and farmers needed harvesting equipment. The Holts shifted focus to building combine harvesters, machines that could cut, thresh, and clean grain in a single pass. Benjamin proved to be a gifted engineer, designing hillside harvesters with independent wheel suspension that could work on sloped terrain without tipping over. By the 1890s, steam-powered traction engines were replacing horses for pulling harvesters and plows, but these machines were monstrously heavy, often weighing over 1,000 pounds per horsepower. In the hard-packed soil of the Midwest, they worked adequately. In California's Delta region, where decomposed vegetation created soft, spongy peat soil, they were disasters. Holt experimented obsessively, trying to distribute weight more effectively. He built tractors with enormous wheels, hoping that greater surface area would prevent sinking. It didn't work. The machines became so wide that moving them between fields was impossible. Holt spent hours in his private workshop, sketching designs and calculating load distribution. The problem haunted him. There had to be a way to move heavy equipment across soft ground. The solution came from observing how tracks distribute pressure. A wheeled vehicle concentrates its weight on small contact patches where the wheels touch the ground. A tracked vehicle spreads the same weight over the entire length of the track, in contact with the soil, reducing ground pressure dramatically. Holt wasn't the first to conceive of tracked vehicles. Designs dating back centuries existed, but none had been commercially practical. In Britain, Richard Hornsby and Sons had built a tracked tractor in 1905, but the British military showed no interest, and Hornsby eventually sold the patent to Holt in 1914. Holt's genius was in making the concept work reliably and affordably, turning an experimental idea into a mass-produced machine. By 1908, Holt had replaced steam engines with gasoline power, producing lighter, more efficient tractors. The Caterpillar became commercially successful, selling to farmers in Louisiana's swamps, Washington's forests, and anywhere wheeled equipment couldn't operate. The tractors also proved useful for construction, hauling materials across rough terrain where roads didn't exist. In 1909, Holt opened a factory in Peoria, Illinois, targeting Midwest farmers. By 1914, over 2,000 Caterpillar tractors were operating worldwide in at least 20 countries. Holt's company was thriving, manufacturing agricultural equipment for peacetime markets. When war broke out in August 1914, Holt expected demand for tractors to decline as European markets closed. Instead, demand exploded. The Western Front in France and Belgium had degenerated into static trench warfare by late 1914. Armies entrenched along a 450-mile front from the English Channel to Switzerland, protected by barbed wire, machine guns, and artillery. Any attempt to advance resulted in catastrophic casualties. The ground between opposing trenches, constantly shelled and churned by explosions, became impassable mud. Horses couldn't cross it. Wheeled vehicles sank. Yet armies needed to move supplies, haul artillery, and transport troops. The British and French armies, desperate for solutions, purchased Holt Caterpillar tractors. The machines could haul heavy guns through mud that stopped everything else. By 1915, hundreds of Caterpillar tractors were working behind the lines on the Western Front, and military observers were beginning to see possibilities beyond hauling supplies. Colonel Ernest Swinton, a British Army officer serving as an official war correspondent in France, watched Caterpillar tractors moving supplies and artillery through mud in late 1914. Swinton, an engineer by training, had received a letter before the war from a friend describing the Holt tractor's capabilities, but he hadn't paid much attention. Now, watching the machines crawl across terrain that would stop any wheeled vehicle, Swinton had an epiphany. On October 19th, 1914, while driving from St. Omer to Calais, the idea crystallized. An armored vehicle on Caterpillar tracks, armed with machine guns, could cross trenches and barbed wire, bringing firepower directly to enemy positions. The machine would be invulnerable to small arms fire and capable of advancing where infantry couldn't. Swinton called it an armored machine gun destroyer. Swinton wrote to Maurice Hankey, Secretary of the Committee of Imperial Defense, proposing the construction of tracked armored vehicles. Hankey supported the idea and forwarded it to Winston Churchill, then First Lord of the Admiralty, and David Lloyd George, Minister of Munitions. Churchill, frustrated by the stalemate on the Western Front, was already exploring alternatives to trench warfare. In June 1915, Churchill and Lloyd George attended a demonstration at Wormwood Scrubs in London, where a Killen Straight armored tractor, an American design with Caterpillar tracks, cut through barbed wire entanglements. The demonstration convinced them that tracked armored vehicles were feasible. Churchill allocated funding for development, and a secret project began under the code name Landship. The project was transferred to the Ministry of Munitions in September 1915, where it was managed by Albert Stern and a team of engineers. They experimented with various designs, eventually developing a rhomboid-shaped vehicle with tracks running around the entire hull. The shape allowed the vehicle to cross wide trenches, a critical requirement. The first prototype, nicknamed Little Willie, was completed in September 1915, but it couldn't cross trenches wide enough. A second prototype, Big Willie, later designated Mother, featured the distinctive rhomboid shape with tracks extending over the top of the hull. In January 1916, Mother successfully demonstrated the ability to cross 9-foot trenches, crush barbed wire, and traverse shell-cratered ground. The British Army ordered production, and the vehicle was designated the Mark I tank. The term tank was a security measure. To conceal the true nature of the vehicles, workers were told they were building water tanks for the Russian Army. The name stuck. 150 Mark I tanks were manufactured by July 1916, divided equally between male tanks armed with 2 6-pounder guns and female tanks armed with machine guns. The tanks were massive, weighing 28 tons, measuring over 26 feet long, and requiring a crew of 8. They were slow, unreliable, and mechanically complex. The engine, located inside the fighting compartment, made the interior unbearably hot and filled with exhaust fumes. Communication with the crew required shouting over the roar of the engine. Yet they could cross trenches and withstand machine gun fire, capabilities no other vehicle possessed. On September 15, 1916, tanks went into combat for the first time at the Battle of Flers-Courcelette, part of the larger Somme offensive. Of the 49 tanks available, only 31 reached the start line due to mechanical breakdowns. Of those, only 9 successfully advanced deep into German lines. The rest broke down, became stuck, or were knocked out by artillery. Yet even this limited success was shocking. German defenders, seeing armored monsters crawling toward them through barbed wire and machine gun fire, panicked. Some trenches were abandoned without a fight. Prisoners described the tanks as causing superstitious terror. One tank crew commander counted over 40 bullet holes in his armor, none of which penetrated. The tanks proved that armored vehicles could survive conditions that killed infantry. The tank's debut was imperfect but promising. Military commanders recognized the potential, and production accelerated. By 1917, improved designs, the Mark IV and Mark V, addressed many of the early problems. Engines became more reliable, armor thicker, and crew conditions marginally better. Tactics evolved. Rather than deploying tanks in small numbers, the British began massing them for concentrated attacks. At the Battle of Cambrai in November 1917, nearly 400 tanks attacked simultaneously, achieving a breakthrough that had eluded infantry for 3 years. Though the British couldn't exploit the breakthrough, Cambrai proved that tanks, used correctly, could restore mobility to the battlefield. The connection between Holt's Caterpillar tractor and the tank was direct. British tank designs used tracks based on Holt's patents, and many early tanks incorporated Holt components. France developed its own tanks, the Renault FT, using Caterpillar tracks inspired by Holt designs. Germany, desperate to counter Allied tanks, built the A7V, which used Holt tracks and components. Even the United States, which entered the war in 1917, based its tank program on Holt designs. The Holt Manufacturing Company supplied over 10,000 tractors to Allied armies during the war, and the company's expertise in tracked vehicle design made it the de facto consultant for tank development. Benjamin Holt never set out to create a weapon. He designed the Caterpillar to help farmers work soft soil. The military application was entirely unforeseen. When Holt first saw his tractors being used to haul artillery, he was reportedly pleased that his machines were contributing to the war effort. Whether he understood that his invention would become the basis for tanks, machines designed specifically to kill, is unclear. Holt died on December 5, 1920, just 2 years after the war ended, and left little record of his thoughts on the matter. His obituaries praised his contributions to agriculture and mechanized farming, barely mentioning the military applications. After the war, the Holt Manufacturing Company struggled. Demand for tractors collapsed as soldiers returned to farming and surplus military equipment flooded the market. European sales vanished. The Stockton factory, which had employed over 1,000 workers during the war, laid off hundreds. In 1925, Holt Manufacturing merged with its competitor, CL Best Tractor Company, forming Caterpillar Tractor Company. The new company moved headquarters to Peoria, Illinois, and focused on construction and earth-moving equipment. By the 1930s, Caterpillar had become the dominant manufacturer of tracked equipment worldwide, a position it maintains today. The company's logo, a stylized caterpillar, honors Benjamin Holt's original inspiration. The tank's impact on warfare was profound and enduring. World War II was dominated by tank battles, the German Blitzkrieg, the Soviet T-34, the American Sherman. Tanks became the primary ground combat weapon, combining firepower, mobility, and protection. Tactics, strategy, and doctrine revolved around tank operations. The Cold War's military balance was measured in tank numbers. Modern militaries still depend on armored vehicles, now equipped with advanced sensors, composite armor, and computer-controlled systems. But the fundamental concept remains unchanged: a tracked armored vehicle capable of crossing difficult terrain while delivering firepower. Every modern tank traces its lineage to the Mark I, which traces its lineage to the Holt Caterpillar, which was designed to help farmers work soft soil. The story of the Caterpillar tractor's transformation into the tank illustrates how innovations designed for peaceful purposes can be repurposed for war. Holt's track solved an agricultural problem. Military engineers recognized that the same technology could solve a military problem. The transformation was rapid, driven by the desperate conditions of the Western Front. Within 2 years of Swinton's epiphany, tanks were in combat. Within 4 years, they were decisive. The speed of adaptation suggests that technological innovation, once demonstrated, spreads quickly when necessity drives it. Holt's agricultural tractor became a weapon not because Holt intended it, but because war demanded solutions, and Holt's invention offered one. Benjamin Holt's legacy is complex. He is celebrated as a pioneer of mechanized agriculture, a man whose inventions made farming more efficient and productive. The Caterpillar brand is recognized worldwide, synonymous with heavy equipment and construction machinery. Yet Holt's tracks also enabled the tank, a weapon that has caused immeasurable death and destruction. The dual nature of his legacy reflects a broader truth about technology. It is neutral, shaped by those who use it. Holt's tracks moved harvesters through fields and tanks through trenches. The same innovation served both peace and war, creation and destruction. The transformation of the Caterpillar tractor into the tank was not inevitable. It required specific circumstances: the stalemate of the Western Front, the vision of officers like Swinton, the willingness of Churchill and Lloyd George to fund experimental projects, and the engineering skill to adapt agricultural technology for military use. Had the war remained mobile, tanks might never have been developed. Had Swinton not seen Holt tractors in France, the connection might not have been made. Had Churchill not supported the project, it might have been abandoned. The tank emerged from a combination of technological capability and historical necessity, a reminder that innovation is as much about context as invention. The farmers who bought Holt Caterpillar tractors in 1905 wanted machines to work their fields. They had no idea that within 15 years similar machines would be used to break through fortified trenches. The soldiers who first saw tanks crawling toward them in 1916 had no frame of reference for such machines. They were unlike anything in military history. The psychological impact was as significant as the tactical advantage. The tanks shattered the defensive dominance of trenches and machine guns, restoring offensive capability to armies that had been stalemated for years. That breakthrough was possible because Benjamin Holt solved a farming problem in California's soft delta soil. Holt's story fits a pattern repeated throughout history. Innovators solve immediate, practical problems using methodical engineering, Watson Watt built radar to track thunderstorms. Mitchell designed racing seaplanes for sport. Brunel built bridges and ships to connect cities. Harrison built clocks to navigate safely. Semmelweis washed hands to save mothers. The Wright brothers built a plane to satisfy curiosity, and Benjamin Holt built a tractor to work soft soil. None set out to change warfare, yet Watson Watt's radar saved Britain. Mitchell's Spitfire defended the skies. Brunel's engineering principles shaped military infrastructure. Harrison's chronometers guided warships. Semmelweis's antiseptic practices saved soldiers from infection. The Wright brothers' airplane became a weapon, and Holt's tractor became a tank. The connection between the Caterpillar tractor and the tank was direct and acknowledged. British tank designers explicitly credited Holt's design as their inspiration. French and German tank programs relied on Holt tracks or licensed derivatives. American tank development consulted Holt engineers directly. The lineage was clear and unbroken, yet Holt himself remained largely out of the public eye. He was a businessman and inventor, not a military figure. While tanks became famous, their agricultural origins were forgotten. Few people who saw tanks crushing barbed wire on the Western Front knew they were watching modified farm equipment. By the time Benjamin Holt died in 1920, the tank had already transformed warfare. The German spring offensive of 1918 failed, in part because Germany lacked sufficient tanks to exploit breakthroughs. The Allied counteroffensive succeeded in part because British and French tanks provided mobile firepower that could overwhelm defensive positions. The lessons were clear. Tanks were essential, and future wars would be dominated by armored vehicles. Military planners worldwide invested in tank development, using Holt's Caterpillar track as the foundation. The tractor designed for farmers became the template for military vehicles across the globe. The Caterpillar company that emerged from the 1925 merger distanced itself from military applications, focusing on construction and agriculture. Yet during World War II, Caterpillar supplied thousands of tractors to the U.S. military for construction and logistics. The company's equipment built airfields, roads, and fortifications across the Pacific and Europe. Caterpillar tracks moved supplies, hauled artillery, and supported engineering operations. The civilian company remained entangled with military needs, proving again that the boundary between peaceful and martial technology is porous. Holt's invention, designed to solve a farming problem, remained indispensable to armies decades after his death. In the end, Benjamin Holt created a tool. Tools can build or destroy, create or conquer, depending on who wields them. Holt's Caterpillar tractor built farms in California's Delta, harvesting food that fed millions. It also inspired tanks that broke the stalemate of the Western Front, ending a war that had killed millions. Both outcomes flowed from the same innovation, a track-laying system that distributed weight over soft ground. The duality is uncomfortable, but inescapable. Every transformative technology carries this ambiguity. Holt's legacy, like that of every innovator whose work is repurposed for war, is measured not just in what he built, but in what others made of it. The tractor he designed for farmers became the tank that changed warfare, and history remembers both.